In this video, we're looking at the trigonometric reduction formula. You will remember that in the previous video, we showed you the 4 quadrants and we also showed you the right angle triangles in each of these quadrants. In the first quadrant, the angle we used was always called the reference angle. In the second quadrant, if we had exactly the same congruent triangle, but the angle would go from the positive x-axis to the terminal side, and it would be a size of 180 minus theta. We can also call that size the magnitude. The third quadrant, looking at the blue angle, the angle will be 180 plus theta, and in the fourth quadrant, the angle will be 360 minus theta. Now, these three expressions give us reduction formula. What are we going to do with it? We're going to reduce any angle larger than 90 degrees to an angle in the first quadrant. So we only want to work with angles in the first quadrant. So if we get a larger angle, we're going to use these three formula to reduce an angle to an angle in the first quadrant. Let's give you an example. So let's say we have the angle 30 degrees. What would it be in the second quadrant? It would be 180 minus 30, which is 150 degrees. Okay, 180 plus 30, which is 210. And in the fourth quadrant, 360 minus 30, which is 330 degrees. So now we've reduced these large angles to an angle in the first quadrant using these formula. Okay, so let's show you how it works when you have a trig ratio with any angle. This, of course, works for any angle. Okay, so let's take a real example. Let's take sine 330 degrees. Okay. The first question we ask ourselves is, which quadrant is this in? Well, 330 is in the fourth quadrant. The next sign you ask yourself is, how will I reduce 330 to an angle in the first quadrant? Which formula will I use? I call that a reduction formula. And here's my formula in the fourth quadrant. 360 minus theta. Okay, so I have to put in that formula, but now I don't know what theta is, so I'll have to work out theta myself. So that's my formula, and I must put in my own theta. What can you subtract from 360 to get 330? Well, of course, 30 degrees, and that angle's name is theta. Okay, so now, the moment I have my formula, I have to sort out my sign. What will the sign of sine be in the fourth quadrant? Well, cos is positive there, so sine is negative, so it will definitely be a negative. And the moment you have your sine, you can throw away this formula, because you know that in the fourth quadrant, it will be exactly the same x, y, and r ratios as in the first quadrant. The only thing that's changed was the sign. So I can just as well just work with sine 30. How do I know that? Well, if you remember, we had the triangles on the previous page, and they were exactly the same. This was an y, that was r, and this was x, and this was just negative y. So that's why we get a negative. Okay, if you remember your grade 10 triangles, you know that sine 30 is a half. Where does that come from? Well, that was my grade 10 special triangle. There was a 30 degrees, this was a square root 3, and this was a 1, and sine was opposite over adjacent, hypotenuse. Okay, so you have 3 questions. You have the Gauss rule, and you have your reduction formula. Okay, let's do some examples. Typical questions are the following. Well, in the first place, let's determine cos 350. Okay, let's ask all 3 questions. Which quadrant? Fourth quadrant. Which formula? 360 minus something. What would that something be? 345. So theta is 45 here. What is the sign of cos in the fourth quadrant? Cos in the fourth quadrant is positive, so your sign is positive, and you throw away your formula. The moment you've figured out the sign, you take your theta, cos 45, and cos 315 are exactly the same. You just had to sort out the signs. And 45 is also a special angle. If you remember the triangle of 45, that was 2, that was square root 2, and square root 2. So Cos is adjacent over hypotenuse. Okay, let's look at the second example. If there's anything in front, just leave it alone. Look at the sign 240. Which quadrant is 240? It's third quadrant. Which formula am I going to use? 180 plus something. What is the something? Well, 180 plus 60. So my theta is 60. Okay, so I write down my formula, I sort out my theta. Now I throw my formula away because I know 240, sine 240 and sine 60 is exactly the same value except for the sine. Why is the sine negative? Because sine in the third quadrant is negative. And now you multiply the two in, and we know what sine 60 is from the 60-degree triangle, and we get negative square root 3. Okay, the third example, they do not give you a specific angle, they just want you to reduce this formula. Which quadrant is this formula? Third. Okay, so they gave us the formula, and what is the sign of sin in the third quadrant? Negative. So sine 180 plus theta will be exactly the same value as sine theta, only with a negative. Okay, let's do 3 more difficult examples. Here we use an alpha. You can use any angle you like. Tan 360 minus alpha is fourth quadrant. Which formula? It was given. What is the sign of tan? Negative, but there was a negative, so you'll get 2 negatives, which give you a positive. Okay, let's go to tan square 360 minus x. Now this is difficult. The square is a slight problem. Instead of writing the tan, the square between the tan and the formula, it can be written outside, and that is what you must remember. Whenever you do reduction formula, always go and put the square outside. Put in square brackets, put the square outside. Any exponent, even if you have a cubic, a 3 there, it will also go outside. Okay, just rewrite the tan squared as tan 360 minus theta square. Okay, so tan 360 minus theta, which quadrant? Fourth. Formula was given, tan in the fourth quadrant is negative, and now you square, that means take 2 of them. And when you've done squaring, minus times negative is positive, and tan times tan is tan x square. Then you rewrite it from there to there in the proper notation. Okay, so this is very important for example. Let's move over to the last one. Cos in the third quadrant is negative, but I first put out the 3 outside the block brackets I put in. Then I reduce from 180 plus y to y, and I get 3 cos y's. Negative times negative times negative is negative, and then you bring in the notation with the 3 between the cos and the y. Okay, this went quite quick, so it's good to go through it again, please. Okay, where are we going to use this? Well, here's a typical example of the type of sum that you will get. Wow, it looks terrible, eh? So here we have one of those small ones, expressions. There we have another one. There's a third one, and there's a fourth one. Okay, just watch out. There's a negative, and here is, there's a multiplication sign, and here is a negative. So we have 2 terms in the denominator. We already know how to do this one. We've already showed you. It goes all the way. We've already showed you how to do the sine 180 minus x as well as the sine 360 minus x. So you just put in brackets if it's more than one term so that your signs work out properly. Okay. The only problem is if you see a tan, you must always change it to sin over cos. And the moment you have a fraction, all the other fractions, all the other expressions also want to be fractions. Now you can nicely cancel, and then you get minus cos x sin x over 2 sin x, and here we cancel again, and our answer is 1 over 2 with a negative. It gives you negative a half cos x. Okay. I just go through this one again. Goodbye.